second lecture of our chapter number 3, which is the design of industrial building. And in the last lecture, it is already discussed that this chapter is the combination of two chapters in which first chapter, which is design of gantry girder, is already covered, and this is our second chapter of the module of design of industrial building. So students, in the last lecture we will discuss about the basic introduction of industrial building. After that we will discuss about what is the planning and structural framing, which is will which will be kept in your mind while you have to design any industrial site. And after that we will discuss about what is the factor affecting while you have to choose any industrial building, like your industrial building on the main road, availability of raw material, availability of water supply. Okay, so all these things will be discussed in the last lecture. After that, we will discuss of our main component of industrial buildings. Okay, so in main components, there are number of components, like first of all, it is span. So let us discuss what is span. So span is this length. This length is called as span. Second is spacing of roof truss. Students, this revision is just due to this is helpful in today's lecture. Okay, because in today's lecture we will discuss about the examples based on industrial building. So some preliminary dimensions are there. So this is our span. Span means this dimension. Okay, second is spacing of roof truss. So whenever you can see your industrial building from front side, then only two columns are there. But if you are seeing your industrial building from 3D point of view, so you can see that this is your 3D point of view. Okay, now there is number of columns are arranged with some distance based on their design. Okay, now say for example, this is your first column and another column is situated over here, then the distance between these two columns is called as spacing of roof truss. Okay, now this called as purlin. The member which is supported roofing material is called as purlin. The topmost portion, the topmost purlin is called as ridge point. So this is the ridge point. You can see that this is ridge ventilator, and last, both the last and purlins is called as eave purlin. You can see that over here it is eave purlin. Okay, now the vertical distance from the main tie and the top of the portion is called as rise. Okay, so this is our rise portion. If we have to find out the slope, what is the value of slope, then the horizontal is alpha. So this is alpha with respect to horizontal. So if we have the value of rise and we have the value of span, then what is the equation of alpha? Then you can see that tan alpha is rise divided by span by 2. Okay, so all these things are useful in today's session. Okay, now let us start our today's session, in which first of all, how the load transfer from one member to another member. So you can see that at this point there is two purlin. First purlin at this side and another purlin at this side. This side's purlin support this side of roofing material, and this side of purlin is supported to this side of roofing material. Okay, now this is your first purlin, this is your second purlin, and this is your last purlin. Now you all know that load transfer half from left side and half of the right side. At the similar portion from this length, half of the load is transferred to the left side and half of the load is transferred to the right side. It means your all this purlin, which is called as intermediate purlin, takes full load, because half from the left side and half from the right side. On the similar way, both the end purlin, which is eve purlin and ridge purlin, takes half load because it is only coming from only one direction. Okay, so you can see that our theory name is panel point. So all these points are called as panel point. Junction points is called as panel point. Okay, so this is not a new word because panel point word is already discussed in our foot over bridge. Okay, so what is panel point over here? So panel point is like this. You can see that it is a rounded portion is called as panel point. Now, as discussed earlier that this is our end panel point because it is our end of the roofing material and supporting system. And second is intermediate panel point. So this is our intermediate panel point. These two are okay. Now you can see that your end panel point is also called as half panel point. So it is obviously and it is already discussed that your end members takes only half load while your intermediate panels takes full load. That's why its name is full panel point. Okay. So students, this is theory of panel point in which member takes how much load. Okay. After that, these five are the preliminary dimensions while you have to start to calculate dead load, live load and wind load. Okay. So students, this is the very most important five preliminary dimensions which is useful in your example number 1. So you can see that our first preliminary dimension is called as pitch. Now what is pitch? Pitch means rise divided by span, so it is called as pitch distance. Okay, and whenever this pitch distance is not given in the question, then you have to assume that it is in the range of 1 by 3 to 1 by 5. Okay, so this is our pitch distance. Second is angle of roof truss. Now, angle of roof truss is already discussed that if alpha is the angle with respect to the horizontal, then what is the equation of tan alpha? It is rise divided by span by 2. So you can see that it is rise by span by 2. Okay. Now the value of rise is given in the question. The value of length is also given in the question. Then our third member is length of PR. PR means principal rafter. It is already discussed that in the last lecture that this is our principal rafter. So this is our principal rafter. So what is this length? So we have to find out this length with the help of Pythagoras. So you can see that what is the length of principal rafter? It is 1 by 2 means under root r square plus l by 2 square. It means under root r square plus l by 2 square. So we will get our answer length of principal rafter. Now these two terms are very most important. Okay, I repeat these two terms are very most important. So students, you can see that our fourth is half planned area. Half means we have to consider this half portion, not consider this portion. And second term is plan. It means we have to see it from the top of the view. So whenever you have to see it the top of the view, then we have to visual only this length. This length is L by 2. So you can see that this is L by 2 into spacing of roof truss. It means the distance between these two columns. Okay. These two columns distance is called as spacing of roof truss and it is already discussed earlier in today's session. And our fifth definition is half slope area. Similarly, half means we have to consider only this portion. Second is slope. It means we have to see the slope area. So that's why Whenever you can see the slope area, then you have to visualize your this length. And what is this length? This length is length of principal rafter. Okay. So this is length of principal rafter into spacing of roof truss. Okay. So students, I think there is no any doubt. So these five are the major preliminary dimensions whenever we have to calculate dead load, live load and wind load on any industrial building, then this is the basic steps. Okay, now we are moving further to which are the loads we have to calculate when we have to design any industrial building. So first load is dead load. Now as you all know that the calculation of dead load is as per IS 875 part 1. Second is live load. So live load is calculated as per IS 875 part 2. Third is wind load, and wind load is calculated as per IS 875 part 3. Fourth is snow load. It is 875 part 4. Fifth is earthquake load, and nowadays earthquake will be calculated as per IS 1893 2016, but in your syllabus old course and old code which is IS 1893 2002 are there. Sixth is erection load, and last is load due to temperature, creep and sinkerage. Okay, so students, in your syllabus the first five loads are there, but most of the times first three loads are in your GTU exam. Okay, so students, as per IS 875 part 1, which are the main four load which have to calculate in dead load calculation. So you all know that dead load, in dead load first load is this, it is roofing material. Okay, so you can see that what is dead load calculation. In dead load calculation on a roof truss comprises of roofing material, purlin. So you can see that this is purlin and sulfate of purlin is also be there. Sulfate of truss. So this is all the sulfate of trusses. And at last wind bracing. Okay, so wind bracing is not see, you can see that over here, but wind bracing will be like this cross bracing over here. Okay, so these four loads you have to keep in your mind whenever you have to calculate a dead load on industrial building. Now what is the assumptions? Okay, so first is roofing material. So it is already discussed in last lecture that in roofing material we have to use two types of material. First one is GI sheet. GI means galvanized iron sheet, and second is ACC sheet, asbestos concrete cement or cement concrete sheet. Okay, so these two materials are there for we have to providing roofing material. Now whenever there is no any clarification regarding what is the sulfate of these two materials, then we have to assume is in the range of, for GI sheet it is 120 to 130 Newton per meter square, and for ACC sheet it is 120 to 150 Newton per meter square. And these two loads are considered on slope area because this is for slope. Okay. Second is sulfate of purlin. Now another three loads are calculated as per half plan area, and only this load is calculated as per half slope area. Okay. Now second is weight of purlin. So sulfate of purlin is not given, then you have to assume that in the range of 60 to 90 Newton per meter square. Third one is sulfate of roofing material or sulfate of truss. Now, this equation is given on IS 875 part 1, in which the equation is 10 into span by 3, it is L by 3 plus 5 Newton per meter square per plant area. And at last, it is wind bracing. So wind bracing sulfate is in the range of 12 to 13 Newton per meter square whenever it is not given. Okay, so these four are the dead loads whenever we have to design for industrial building. Next is live load. So students, in live load calculation, there is two cases are there. First, when your alpha is greater than 10 degree, and second is when your alpha less than 10 degree. Okay, so let us see what is the assumption in live load calculation. So in live load calculation, first is live load on purlin will be calculated for alpha greater than 10 degree. Then the equation is 750 minus alpha minus 10 into 20 Newton per meter square, and this load will also be calculated per half plan area, and this answer will not be less than 400 Newton per meter square. Okay, so students, this is the equation for alpha greater than 10 degree. Now for alpha less than 10 degree, you have to assume that the live load on purlin is equal to 750 direct, because whenever alpha is less than 10 degree, then this term is in the negative form. Okay, so whenever this term is in the negative form, then all the term will be neglected, so your answer is 750. Okay, so you can see that if this answer is less than 400, then minimum load 400 Newton per meter square is taken. Now, this is the live load on purlin, but we have to transfer it to the main truss. So, what is the live load on a roof truss? It is 2 by third of a live load on purlin. Okay, so this all the things will be clear in our example. Okay, and our last load, which is wind load calculation. So in wind load calculation, there is 80 percentage of similarity which will be discussed in our semester 7. So in semester 7, our first step is to find out design wind speed, which is denoted by Vz or Vd. Now Vz or Vd is equal to Vb into K1, K2, K3. Now what is Vb? Vb means basic wind speed, and it is depend on the location. K1 is risk coefficient, K2 is terrain height category, and K3 is topography factor. So all these things are aware. Okay. Now second is design wind pressure. So this equation is also given on page number 12 of IS 875 part 3, and the equation is zero point 0.6 into Vz square. Now this equation will not cover in our semester 7, and it is F is equal to CPE. It is plus or minus, but why we have to select minus, we will discuss later in the next lecture. Okay, so it is CPE minus CPI into A into PZ. Now what is CPE? So CPE is our external pressure coefficient, and CPI is our internal pressure coefficient. Okay, so students, these are the major three loads which we have to calculate it while we have to design for industrial building. So this is our first type of example. Now in the second type of example, we have to design for purlin. So whenever we have to design of purlin, there is two types of examples are there. In the first types of examples, this all the loads calculation is directly given. Say for example, the load on purlin is 3 kilonewton per meter, so you have to design for purlin like this. And in second type of example, first of all, you have to find out dead load, live load and wind load. After that, with the help of load combination, you have to find out load And after finding out load, you have to design for purling. Okay, so this is our first type of example. In second type of example, our design of purling. Now, for purling member, there is three types of sections are there. Okay, so in the first type, the section is angle section, and this angle section is generally useful when the spacing of roof truss is in the range of 3 to 5 meter. Our second is channel section. This channel section is useful when the spacing of truss is in the range of 4 to 6 meter, and when the span of roof truss is very large, then we have to use I. It means girder channel for purling. Okay, girder purling. So this is the three components, and this is the three section which we have to use for purlin design. Now it is discussed in the last slide that whenever we have to design for purlin, we have to find out two types of examples are there. In the first types of example, the load is directly given, and in the second type of example, first of all we have to find out dead load, live load and wind load, and after that we have to design for purling. So which are the load combinations is useful while you have to design for purling? So it is dead load plus live load. Second is dead load plus wind load. And third is dead load plus live load plus wind load. So you can see that there is no any factor of safety. It means there is no any 1.5 multiplications are there in all the load combinations. It is just because of in industrial building your load is considered as your factor load. Okay. So students, this is the end of our today's session. In the next lecture, we will discuss up to our example number 1. Okay. So students, this is the end of our today's session. Thank you.